Hi everybody, sumchief here. Today we're looking at quadratics, specifically how to factor a quadratic, what it is we're trying to achieve when we factor a quadratic, and the simple steps we need to follow in order to achieve this. So let's have a look. Okay, so why would you want to factor a quadratic? Well, there's more than one reason. Most common ones is to solve for when either x equals 0 or y equals 0. When x equals 0, the graph intercepts the y-axis. That's the axis here. And when y equals 0, the graph intercepts the x-axis. This is the x-axis here. So, got three examples of quadratics: x squared plus 2x plus 1, x squared minus 4, and x squared minus 2x plus 4. And you can see that these three graphs behave differently. We've got this one here, x squared minus 2x plus 4, doesn't intercept the x-axis anywhere. You've got x squared minus 4, which intercepts the x-axis twice, namely here and here. And then you've also got x squared plus 2x plus 1 only intercepts the x-axis in one place, namely here. Now all these graphs, you'll notice, intercept the y-axis. So I just circle around here and here and here. Okay, so let's have a look into this a little bit further. So every quadratic is in the form of ax squared plus bx plus c, where a is never 0. If a equals 0, then all we're left with is a simple linear equation or a straight line, which would be something like this. And that's going to be pretty easy to solve because it's just a simple equation. So now we are looking for values of x, so we can calculate where the function will be at y equals 0. So when y equals 0, we'll be touching this x-axis here. Now the red arrow shows intersection of the x-axis on this graph here, which is here and here. And the purple arrow shows the intersection of the y-axis here. So when the graph intercepts on the y-axis, that's when the function is at x equals 0. When the function hits the red arrows, that's the value of the function when y equals 0. Let's look into that a little bit further now. Okay, so we've got a little example of a function here. Our quadratic in this case is x squared plus 6x plus 8. And I've aligned it up with the c and the b and the a values. So first thing we see is that a equals 1. I've not put a 1 in there, but if you put a 1 there, it would not alter the value of this quadratic at all. So a equals 1, so that's good. So then we see that c equals 8. So when c equals 8, we need to find factors of 8. So this is pretty straightforward. Plus and minus 1, plus and minus 2, plus and minus 4, and plus and minus 8. And we tend to line these up with the first and the last and the middle two like that in this example. So we want these factors of 8 that add up to plus 6. So let's go through the system and work it out. So plus 1 and plus 8. So plus 1 times plus 8 equals plus 8. So that's good. And minus 1 times minus 8 is also plus 8. So that's all good. But what we see is that they don't add up to plus 6. So plus 1 plus 8 is 9. And minus 1 plus minus 8 is minus 9. So that's not 6. So this one's no good. Okay, so now we see we've got plus 2 plus 4. So plus 2 times plus 4 and minus 2 times minus 4 are both plus 8. So that's looking promising. So now we see plus 2 plus plus 4 equals 6. So that's looking spot on. So this is what we want. So when we get the plus 2 and the plus 4, we can multiply them together and get 8, and add them together and get 6. So that's good. So next we set up the brackets with x's inside, x plus 2, x plus 4, which is basically what we've done. We've factored it out. So now what we do, we just check our result for the factoring. So we've got x times x, when we FOIL it out, gives us x squared. X times plus 4 gives us 4x. Plus 2 times x gives us 2x. And plus 2 times plus 4, which gives us plus 8. Simplify this up a little bit, we get x squared plus 6x plus 8, which is back to where we started, so we've checked everything's good. And just to have a look at this function, so when we've got x plus 2, which is this one on here, when x plus 2 equals 0, we're left basically x equals minus 2, and there x equals minus 2, that's this place. And x plus 4 equals 0 means x equals minus 4, and there we go. So basically we've worked out here by factoring that when we've got x plus 2 times x plus 4, our graph will intercept the x-axis at minus 4 and minus 2. So that's great. Okay, let's try another example. So this time we've got x squared minus 7x plus 10. So straight into it, see a equals 1, can put the 1 there, that's fine. So we see the c value is plus 10. So c equals plus 10. So now we find factors of 10. And these ones are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So back to our little basic here. So factors of 10, that add up to minus 7. Okay, so we always start from the out in, going like this, link these ones up, because we want them to multiply together to get 10. Okay, so we've got plus 1 times plus 10. That gives us plus 10. And minus 1 times minus 10 also gives us plus 10. So that's what we want for the c value. But these do not add up to minus 7. Plus 1 plus 10 is 11, and minus 1 plus minus 10 is minus 11. So that's no good. So now we look at the plus 2 times plus 5, which is plus 10, and minus 2 times minus 5, which is plus 10. Okay, that's good. So now we see plus 2 plus 5 is plus 7. That's no good. We've got minus 7. And then minus 2 plus minus 5 gives us minus 7. There we go. That's looking really good. Okay, so then, as we do, set out our brackets. So we have x minus 2 and x minus 5. Okay, so just foiling them back out again. So x times x gives us x squared. X times minus 5 gives us minus 5x. Minus 2 times x minus 2x. And minus 2 times minus 5 gives us plus 10. Simplifying this up, we get x squared minus 7x plus 10, which is back to where we started. So just see what happens with this on the graph. So we've got x minus 2, which when you solve it for x, you get x equals 2, which is here. And when you've got x minus 5 equals 0, solving again for x, you get x equals 5, which is here. So there we go. We've seen then on the graph that the quadratic will intercept the x-axis at plus 2 and plus 5. So there we go. There we go. We've solved this one. On to the next. Okay, so now again we've got x squared minus 3x minus 18. So this time we've got a minus and a minus. So this one's going to be a little bit more tricky in working out. So straight away we see a equals 1. So we can put a 1 there if we wish. So we see c is minus 18. So that's the value of c. So now we want factors of minus 18. There's a few more factors involved in this one. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. So again, starting from the out in, linking these up, we go this way. Okay, so we see plus or minus 1 times plus or minus 18 will give us plus or minus 18. But there's no way that any of these are going to add up to minus 3. So that's no good to us. And then we've got plus or minus 2 times plus or minus 9. That will give a plus or minus 18, which is fine. But again, difference between these is always 7. So that's never going to add up to minus 3. So that's no good to us. So on to the last choice. We see that plus 6 times minus 3 is minus 18. That's promising. And minus 6 times plus 3 is also minus 18. So that's promising. And then we see, looking at this one here, because we got minus 3x, so the minus should be on the bigger term, which is the 6. We see minus 6 plus minus 3 gives us minus 3, which is our b value. So b is minus 3. Okay, so now we just go straight ahead, put them into our brackets, and check it out by foiling. So we've got x minus 6, x plus 3. Multiply this out. X times x, x squared. X times plus 3 plus x plus 3x. Minus 6 times x minus 6x, and minus 6 times plus 3 minus 18. Simplifying this out, x squared minus 3x minus 18, back to our original quadratic. So there we go, we've proved that we've got the correct answer. So let's just solve it for x. So x plus 3 equals 0, which means x equals minus 3. So that's going to be this one. And x minus 6 equals 0 gives us x equals 6. So that's that one. So there we go. We found out what's happened with this quadratic. So that's that solution there. Okay, onto this one here, which is a special case. So straight into it, we see a little bit different to what we've been doing so far. We've got x squared minus 16. No b term here, no bx. Okay, so it's no problem. All this means is that b equals 0. So basically, you could just rewrite this as x squared minus 0 times x minus 16. Okay, so see straight away, a equals 1, as always, that's fine. C value is minus 16, which is here. So now we need factors of 16, or minus 16. So we've got plus minus 1, plus minus 2, plus minus 4, plus minus 8, plus and minus 16. So going from the out in, as we did before, see we've got a stationary term in the middle on its own, plus or minus 4. So again, let's just go through it, through the system. So plus and minus 1 times plus and minus 16 gives us plus 16, plus and minus 2 times plus and minus 8 also gives us 16. But none of these terms here will ever add up to 0, so they're no good. So here we've got the plus and minus 4 on its own. So when plus and minus 4 is on its own, we've basically got plus 4 times minus 4 equals minus 16. That's all we can check there, that's all we've got to get a minus. And we also see plus 4 plus minus 4 equals 0. And as we said here, the b is 0. So in this term here, where we written down at the top just to check, we put a b equals 0. So that's good. And this is a special case because this one is a difference of two squares, and you'll come across this quite often through all your mathematics you might study in the future. So anyway, let's go finish off with the factoring for plus and minus 4. So we put x minus 4, x plus 4. FOIL it out, x times x, x squared, x times plus 4, plus 4x, minus 4 times x, minus 4x, and minus 4 times plus 4, minus 16. Simplify this out, we get x squared minus 16, which is basically where we started off. Well, that's great news, so we've checked we've done the right thing. So now solving for x. So we've got x plus 4 equals 0, x equals minus 4. So that's going to be this one here. When x minus 4 equals 0, x equals plus 4. It's this one here. So that's what happens with this function here. So one little interesting thing you might see here on this function, difference of two squares, the line for the quadratic, as you see here, the lowest point of that quadratic will be right there, right in the middle where y, on the y-axis, where x equals 0. So that's the lowest point of the graph. If it was minus x squared, the quadratic could be going this way. Let's put that better for you. It would be going this way, because minus means it would be upside down quadratic, and that would be the highest point, would be when x equals 0. So there you go, that's a special case, the difference of two squares. Okay, so thanks for watching. Leave any comments below. There's a solution for any question you want to see. Put it in the comment box below. I'll do the best I can. And as always, please remember to subscribe. Thanks for watching.